Let's learn about single replacement reactions using the analogy of dancers out on the dance floor. In a single replacement reaction, you have a pair of particles who are currently bonded. So this is a pair of dance partners dancing together right now. And then elsewhere out on the dance floor, you have someone dancing solo. This is an atom or a particle that is not currently bonded to these. This solo dancer is often a metal or sometimes a halogen. And what this solo dancer does is he cuts in. He comes in here and he kicks out one of those particles from that bonded group. And now that dancer, who was once in a pair, is now dancing solo. We're going to head into the lab and do a single replacement reaction with iron 3 oxide and aluminum. In this reaction, the iron 3 oxide is the bonded group, the pair of dancers, and the aluminum is the solo dancer who's going to come in and replace one of those dancers. So let's head into the lab and check out that reaction. I'm going to demonstrate a single replacement reaction. In this reaction, I'm going to react aluminum metal with iron oxide. So I have mixed my reactants, my aluminum metal and my iron 3 oxide. And while I light that, I want you to think about what products might result from this reaction. And remember that this is a single replacement reaction. So what products do you think we'll get? And so here we go. All right, you may notice that those products are glowing. That is because what has been produced is iron metal. So this is a really rapid, powerful redox reaction, single replacement reaction between aluminum metal and iron oxide. So in the single replacement reaction we just saw, we had Fe2O3 plus Al, aluminum, and that produced some products. Now, based on the way that a single replacement reaction works, you might have been able to figure out that the products in that reaction were aluminum oxide, its formula would be Al2O3, plus iron. In fact, iron was that glowing, bright orange-yellow goo at the bottom of the beaker. This particular reaction is also tremendously energetic. It puts out a huge amount of heat, enough to liquefy the iron. Now remember, using our dancers on the dance floor analogy, what's going on here is that we have this pair of particles. We've got the iron, we have the oxide. Over here is the aluminum. When this reaction took place, the aluminum came in, kicked out the iron, and the iron ended up by itself. This is why we had this molten iron in the bottom of the vessel once that reaction had taken place. The iron was actually kicked out of the iron oxide. And if we were to illustrate what the particles were doing in the single replacement reaction, it might look a little bit like this. Here is the iron oxide, and here is the aluminum. When this rearrangement or replacement takes place, the aluminum comes in, kicks out the iron from the iron oxide, the iron is ejected and becomes a solo particle, and this is what our products look like. The balanced reaction would be written like this. So, it's a great example of a single replacement reaction.